And we should be ready to get going. Once again, good morning, good noon, or afternoon, and welcome to today's webinar on AI agents and how to build your own. My name is Nikolai, and over the next 45 minutes, we'll dive deep into the emergence of autonomous agents, how they differ from traditional AI systems, and how agents can be used to build more agents. Yes, that's right, agents building agents. We'll finish with a demo to tie it all together. Once again, my name is Nikolai. I'm the product lead here at Ancode, and I'm joined here today by Oscar, our ML solutions engineer. We're from Ancode, a data development platform for AI teams to automate data in a single platform. Over the past 4 years, we've built a comprehensive and collaborative set of tools to handle all of your AI data workflows in one place. From data management and curation to automated labeling and humans in the loop workflows and model evaluation to find and debug edge cases and model errors. Today, we'll be covering a bunch of different things. First, we'll start with the rise of agents and agentic AI to ensure we're all on the same page with the different definitions. Then we'll do a comparisons, agents versus traditional AI. After that, we'll move on to more advanced concepts, agents building agents. And finally, we'll give you a demo of an agent-driven workflow in the Ancode platform. Feel free to relax today. There won't be any pop quiz, but I hope you'll leave with a clearer understanding of how agentic AI is reshaping the world around us. If you have any questions along the way, please feel free to pop them into the chat, and Oscar and I will take them at the end during our Q&A. But now, let's get started. So what exactly is an agent? Simply put, an agent is an autonomous AI-powered system that can take actions in an environment. Essentially, a goal-driven system capable of interacting with the external environment without any human interaction. We've come a long way from rule-based systems that could only perform predefined sets of tasks. Thanks to advances in deep learning, reinforcement learning, and cheaper and more scalable cloud computing, we now have agents that can handle dynamic and real-world environments. Think of autonomous vehicles like Waymo, Cruise, or Tesla on the streets of San Francisco. These cars don't just follow a set of rules. They navigate complex environments, respond to changing conditions like traffic, pedestrians, weather, or bikes on the road, and make decisions in real time, all without human intervention. And agents are on the rise. Investors are pouring in, and the market is forecasted to grow heavily over the next 4 to 5 years. There's a lot of real-world use cases hitting the news with proven return on investment. One example that I think all of us have seen is the Klarna use case, where they've used AI agentic workflows for their customer service to essentially render most of their support workforce redundant, resulting in better results for the customer and massive savings on their end. I found another great example last night from yesterday's AI Tools in London event, hosted by Microsoft. Here, Satya Nadella was on the stage for 1 hour and presented about the future of AI agents as Microsoft see it. If you haven't seen it yet, I highly recommend it. I'll leave a link here at the bottom of the slides that we'll be sharing afterwards. But essentially, he's talking through how Microsoft see the future of agents. Instead of using a single AI performing a narrow set of tasks, Microsoft envisions organizations using multiple agents, all working together autonomously. These agents will range from simple prompt and respond assistants to fully autonomous systems capable of orchestrating complex business processes on their own. So everything from procurement, support, sales and marketing, product development, you will have agents that are specialized in each of the different functions within an organization. The thing I take away here, and that surprises me, is that they see that every organization will have this constellation of agents. So instead of having one agent or one model to rule them all, they believe in multiple smaller models and smaller agents that can take care of different processes within an organization. I know, of course, Microsoft is bullish on AI, but with their sway within the white-collar office work industry, it seems like they're ready to make this happen. And while we talk a lot about these AI agents today, it's important to remember that the concept of agents isn't exactly new. So back in the 90s, we had the early versions of rule-based agents. You can think of systems or simple automation bots that followed strict rules and predefined scripts. In the 2010s, we got a host of new rule-based agents into our life as well. Amazon Alexa, Siri, Google Assistant, all different agents that could help us in our day-to-day life. But the major difference between then and now is that today's agents aren't just following a set of instructions. They're adaptive, they're learning, and they're making real-time decisions based on the data that they interact with, so the world that they interact with. They evolve, and that's where the power lies. Take, for example, something like Clippy from Microsoft Office. Yes, Clippy was actually an early agent, if you could call it that. But Clippy didn't adapt and didn't learn from its mistakes. But modern agents, like what Satya and Microsoft envisioned for Copilot, or Tesla's Autopilot, should act on their own, learn from user interactions, and improve over time. So to sum it all up, the difference between the old agents and these new agents, or agentic AI, as some folks will call it in the industry. Old agents operate based on rules. They did what they're told and nothing more. They're limited and often required human updates, be it software or hardware updates, when the environment were changing, or as we call it in the machine learning world, when the data was drifting. If a new scenario arose, they had no way of adapting to it. New agents, on the other hand, are adapted and autonomous. They leverage data and machine learning models to update themselves in real time. And these agents make decisions based on the current information and all of their past experience. And they continuously improve over time. So you can think of the old agents like a robot on an assembly line. It's good at doing one thing, but very inflexible to change. So if you have a new type of packaging the next day, you'd have to reprogram and reset up the whole agent. New agents are more like self-driving vehicles where they adapt to the different conditions, whether it be new roads, traffic, user behavior. However, with all of this excitement and hype around AI agents and their capabilities, it's always important that we try to ground ourselves and get a realistic view of where we actually are today. To this, we can think of AI agent development along two dimensions: level of autonomy and level of adaptability. Level of autonomy defines how independently a system or an agent can operate without any human intervention or human in the loop, here visualized on our x-axis. Level of adaptability, so how well can the system learn and adjust its behavior based on new data and new experiences. Y-axis here. So let's try and plot some products on it. We can see here we had our old world down to the bottom left and our new world top right. Of course, Clippy, Siri, Google Translate, Alexa, and so on, they're definitely in this old world. They're not very adaptable and they're not very autonomous. You could say that a tool like Amazon is in some way autonomous, because I could ask my Alexa to add certain things to my shopping list and execute the order. So it can act autonomously, but in terms of adaptability, it has a predefined set of rules that it follows. Next, we can talk about what Apple is planning to do with Apple Intelligence and Copilot is planning to do. So Microsoft is planning to do with Copilot. So here we have a certain level of adaptability in that it can adapt to a changing knowledge database or a changing set of records that it can reference. It can adapt based on what you tell it. So you can imagine if you prompt ChatGPT or Claude, it can kind of adapt to the different prompts that you give it, but it's not fully autonomous yet. If we look at, for example, the new O1 models from ChatGPT, we're getting more and more autonomous in that it can continuously prompt itself to refine its answer or refine the flow that it's doing. But no matter what you do with ChatGPT, you still have to go in, copy the code and add it into your editor, or copy the receipt and add it into your system. You can also talk about cars like Waymo, where it gets a little bit more autonomous. There's a higher adaptability to the road, but there is still a kill switch on a lot of these cars where human beings are there to be able to intervene if something happens. So we're somewhere here in the middle between mid-autonomy with some adaptability. We're not yet in the future where agents can truly operate without human oversight, but we can envision it. And this is what you see a lot of companies are starting to do now in their pitch decks, their keynotes on YouTube, etc. But we're moving fast and it's in the right direction. So I'm very excited to see what's going to come in the next 3 to 5 years. I'm still thinking about how my Roomba robot at home, or maybe having like an Optimus robot that can help me with different things in my house will look. But let's see. So one thing here is also that we might think, aren't all of these agents just AI systems? Like what is the actual difference and what distinguishes an agent from a normal AI workflow. Maybe Oscar, let's do a little pop quiz, just you and I. What do you think is the main difference between AI and AI agents? And do you have some examples?
Yes, absolutely. So an AI agent will use an AI system to reason. And so basically it will extract the information that it requires to perform a task using the AI. And then using that information, instead of just saying, for example, an event is about to happen in a warehouse, or my car that is in a lane is drifting out of the lane, instead of just providing the alert, it can then actually perform the action to guide the car back into the lane, or raise that alarm, or as you say, to order my shopping from the store, for example. And one example of this, I think, Claude released the latest version of Sonnet yesterday, and that has access to your entire computer, so that you can say, write me a program using VS Code, and it can generate that. Or you can say, add an event to my Google Calendar, and you can perform all of these actions, which the reasoning occurs using AI, but the action is something that you can create in your life. And this is exactly analogous to the example you gave earlier, where enterprises are generating agents to perform product development or sales and marketing in all of these cases too.
Yeah, it also still feels like that a lot of the agents that we're seeing now, they're what I would call like software or digital agents. They're not yet physical or acting in the physical world. Autonomous driving being one of those areas where like we are pretty far ahead. But it feels like the first barrier to break are these digital agents that can go out in the digital world and take action on our behalf, like be it ordering DoorDash or Uber Eats from us, and essentially going from that delivery like end to end. But what we can also see is that like a lot of these AI agents are essentially a lot of AI systems combined, and that is where the real power comes. So like this vision that like Sam Altman or other folks they have around AGI, it kind of feels like that we are brute forcing our way there by combining a lot of different models together to get towards this AGI vision where the consumer or the user will get the feeling that they're interacting with this one mega model, this one mega AGI. But behind the scenes, it can just be like a lot of smaller models, a lot of smaller rules that are combined together.
Absolutely, yes. So having one model that's very good at choosing the right model to apply to a specific task. In the same way that a manager of a team will allocate roles to the right person to perform.
Awesome. Well, then let's see what we got here on the slide that I made. So like the difference is actually that AI systems, they're more static. So they execute predefined tasks and they don't have the ability to adapt dynamically. Of course, you can talk about active learning and different ways of continuously improving your models. But as it is, if a model is in production being deployed, it is not continuously learning. Another example is like Google Translate. It does a really good job at translating, but it won't autonomously suddenly start booking your flights based on your translation request. So you could ask Google Translate, hey, translate this English version of booking a flight into Spanish. You want to just go and like book your flight right after, or at least yet. Let's see what Gemini would look like once it becomes integrated with that translation product. AI agents, on the other hand, here they're autonomous. They can make decisions, act independently, and adapt based on their environment. So they're more goal-oriented, where you give it a more ambiguous goal and it goes and solve that on its own. So like in short, I think we could compare this to that colleague who follows instructions to the last point really well. That's the AI system. An AI agent is more like that rogue team member that we all know who always gets the job done in last minute, often faster and hopefully better, but they have some like new creative solution of how to get there. So on to the next topic of how to use agents to build AI, or how to build agents. So at Uncode, we're taking the concept of agents and applying it to data development. So the process of creating structured data from your unstructured data that you train your AI agents or AI models on. Our agents at Uncode is designed to automate and optimize the most time-consuming parts of your AI development lifecycle. So that's data creation, labeling, and model evaluation. Let's try and break this down just a little bit more for everyone here on the call. So data creation, it's one of the biggest challenges in AI right now, because you want to ensure that you train your agents and your models on the right data. Uncalled agents can help you select and organize the most relevant data subsets or collections for your models. So instead of wasting time on irrelevant and redundant data, you can set up agents to focus on high-value data that improves your model performance. On the labeling side, traditionally, data labeling has required a huge amount of manual effort from overseas and offshore manual workers. With Uncalled agents, we can now automate large parts of this portion of the labeling process, and the agents can essentially perform both pre-labeling, suggesting corrections, maybe flagging edge cases for human review. This dramatically reduces the manual workload while hopefully ensuring a high accuracy and reliability. And lastly, on the label validation. So once the labeling is done, you can have an agent that provides a quality check to evaluate the quality of the labels themselves, ensuring that they meet your quality standard. So this could involve analyzing the performance of a model on those labels or checking the consistency and accuracy according to predefined metrics. Poor quality labels will then be flagged for review for further refinement or editing. This concept of agents building AI or agents building agent is all about scalability. As we want to train larger and larger models or more comprehensive and complex agents, we need scale and we need a lot of data. By creating workflows that can be automated and that can handle large volumes of data with minimal human oversight, our agents allow companies to develop high-quality training data sets faster and more efficient. While Copilot is mainly working with structured data or tabular data, so this is the Microsoft Copilot, our agents have been suited and built to work with unstructured and complex data. So this is a lot of multimodal data from images and videos to audio and multi-page PDFs. And thus, we're probably even further behind on the adaptability part and thus have to include more forms of rule-based actions that you see in a minute. So if we go back to this one here, we're further down on the adaptability in that we're working with very unstructured and complex data. Super. So quickly to put this into perspective before we jump into the demos, we need to understand what it takes to build an AI system. It takes a large team of engineers, researchers, and product managers with access to a model, compute, and data. So the models, a lot of the good models are already open sourced, and you can take those and train on them further, so fine-tuning. Compute is widely available via cloud or buying own compute racks at your own site, and data. So data is your only proprietary piece of the pie, and often quoted as the most cumbersome part of this holy trinity of building models. And you need a range of different tools and processes. So as you can see, from data cleaning, curation, annotation, model training, and model evaluation. And along the lines, you want to visualize your data, you want to orchestrate your workflows, maybe you want to evaluate the quality of your labels, you want to version your data sets and labels, and you want to monitor. So all of these processes and tools is what we at Uncode want to consolidate into one platform where your data don't have to leave or undergo any migrations or movement. We have found that agents can help significantly speed up and scale certain parts of this process, which is what we want to show you today. So mainly cleaning, curation, annotation, and label quality. We're mainly going to talk about the annotation and label quality, but a later webinar will also show cleaning and curation. With that said, let's dive into it. Oscar, I'll hand over the screen to you and let you take it from here.
Fantastic. Thank you so much, Nico. So we're going to start off with an annotation agent demo. So what we'll do is we will start off by looking at the underlying data. As Nico mentioned, this is often seen as the hardest part of the problem to solve. So here we are looking at our data queue. And so let's open up an example image. We can see here that we have a construction diagram that contains images and also has text in there as well. And so we have these drawings that dictate what type of building we have, and we want to extract the description. We want to extract the type of building from a multiple choice option. And then we also want to extract what room types are in there as well. So this could be especially helpful for like a kind of construction site management. If we have lots of unstructured documents with no helpful tags, we need to extract this information, or even if we were training a RAG model that we needed to extract text from these fields, we could do so by running our agent. And so here we can see the actual agent itself. Now, what the agent itself is doing, so in production, this would typically be hosted in some kind of API or cloud function. And so what we are doing is we are connecting to our workflow. So this workflow is showing that this stage is where we have our 9 images at this point. So we can see GPT-4o annotation stage. And then we can pass this on for a human reviewer to make any annotations or changes, and then a peer review process to check each other's work.
Oscar, I'm just going to pause you for a second. I see in the comments that people can barely see the text. So if you can zoom in once or twice, that'll be helpful.
Yes.
Yes.
So that's on the workflow there. Fantastic. And then in the queue, if you're interested in seeing the text on our images, then, or in our documents, then this is containing annotations to say what the different parts of our diagram show. Fantastic. And then
zoom in once or twice. Maybe that's not even possible in PyCharm.
Yeah, no, it's locked in my PyCharm. That's fine though, because we're just going to cover the broad level structure of the code, so we don't need to. And this example we can show after the webinar if it's of interest as well. So essentially, we have this function which is accessing the data in our workflow stage, and then also accessing the label row itself, which is where we can save our annotations. And then that is basically a wrapper for this GPT classification function, where we are taking a text prompt, you're an image analysis expert, and then giving the context for the task. And then what we're doing is we're actually taking those classes that we saw earlier, the text field, and then the checklist, and also the multiple choice nested classification, passing this as a JSON so that the agent knows the output that we're looking to pass this out as. And then this is sending the image itself with the ontology and as a payload. And then we are returning a response and then mapping this to the Encode label format. And so what we can do is we can kick this off. And so now what this will do is this will take each of the tasks, this will run the classification, and then what we will be able to see is we'll be able to see in our workflow, we'll see mirroring this taskbar here, we will see our images progress from this workflow stage through to our human annotation phase. So now if we move through and we go and examine one of our examples of our classification, we can see here that we have this text description. We also have our building type filled in this multiple choice, and we've correctly identified this is a terraced house. So if we zoom in, we can see that we have this house with adjoining property on either side. So it's derived the fact that it is terraced using this information. And then we know it's residential because it's for housing. And you can see also using the checklist, we've also tagged all of the relevant rooms that we can take from this diagram as well. And what this means from a business sense is that as a human annotator or an annotation manager, that my annotators only have to go in and edit these specific fields, and they don't have to go through the tedious manual kind of data entry process of typing out the high-level descriptions.
Super, super cool, Oscar. Can you try and go back to the workflow here?
Yes. So we can see that these are progressed through.
Exactly, and try and click on our workflow graph so we can see. So essentially, you pushed these 8 tasks through your agent, but I assume the idea here is that it should be automatic, right? So how would you recommend setting this up if you want to have it run at scale and automatically?
Yes, absolutely. So what we can do is we can either trigger this via a webhook to say that we have added more data into our project, and then have our agent hosted such that the webhook triggers the agent to run whenever we have new data in. So we don't require somebody to go in and manually trigger this. And then that way we can progress our data through our agent stage.
Gotcha. This is super cool. Should I take a look at the next example now?
Yes, absolutely. Let me stop sharing.
Yes. And I think you should be able to see on your end, and I'm going to zoom in a second.
Absolutely.
I think we can make this a little bit bigger, just for the audience, like that. And then I will zoom in. Yes, so we are back on the agents page. Now we have a new project. Now we're going to see how we can chain together these agents. This is now where the power comes in. Oscar explained the concepts of how to build agents and how to set up a single one, but the power comes when you combine multiple agents into one. So in this case here, we want to be working on a use case where we want to identify license plates on cars and run OCR over them. To show an example of what these cars will look like, it would be something similar to this. So cars from a BDD dataset. They will go through first a grinding dyno plus SAM stage, where we have a hosted grinding dyno that runs bounding box predictions. SAM takes these as a prompt and then spits out the predictions. Then next, we're going to count the objects. So we don't care about images where there's no objects at all, no cars or no license plates. So everything with 0 gets archived. Everything above goes to the next one. So now we have a license plate detector agent. So this license plate detector agent takes a YOLO V8 model that are fine-tuned on license plates and detects only the license plates. If a license plate was detected, send it to OCR. If not, we send it to an expert annotator. And lastly, we run OCR over the particular bounding box that's around the license plate. Before we begin, let's try and curate some data for this. So this particular project is completely empty. We can now navigate to our BDD self-driving vehicle dataset. Here we have 80,000 images from this dataset, and we can now use natural language to find any images of interest. So given that we're going to be looking at license plates, let's try and search for that. So this uses natural language to embed the images and search over them. We can see here there's a bunch of images of license plates. So let's take the first 8 and add them to our license plate collection. Next, I also think I want to add some noise in here just to see if it works, the detection of 0 objects. Let's just search for noise and see if we have some images that are a bit blurry, maybe no objects or something like that. So let's take this, this, and this. We can add that to the same collection, just for the sake of this demo. This can, of course, be done automatically on a scale using our SDK and the different filters that we have. But for this demo, we're just going to do it manually. So we have our license plate collection. We'll now create a license plate dataset that I'm going to add to my project. There we go. So now we have 13 tasks. Then we'll go into our agent. So I've set it up here in a Colab notebook. And what I've done is I've checked my GPU off, downloaded all the repos and packages I need, imported grinding dyno, SAM, my utilities, and we are now ready. So first thing we do is, of course, we set up a SH path and we authenticate. And then let's just take a look at the classes we have at hand. So car, pedestrian, bicycle, and license plate. Next, we're going to set up some prompt functions. So we know that grinding dyno takes text prompts to generate the different boxes. Here it's best to prompt it with just the class A in front and a dot after. This is following best practices of grinding dyno. We'll define a class here for our SAM segment and a class for our classes. Set some thresholds for grinding Dino and some utilities just to make our logging a little bit more pretty. We'll look at it in a second. And then we'll take our project. So this is the project we're looking at here before. We're going to run that one. Let me zoom in here once just so people can see. So now we get to the fun part. We're going to run our stage 1. So stage 1 was this up here. In this particular one, and let me show from start. We take our agent stage. Here, we update our class prompts. And now for each task, we run a model over it. First, we get the particular data asset, we download it, we run a detection on it. So this is our detection with grinding Dino. Then we filter out all the detections we don't want, so the detections that are not in our class ontology. We take that detection and generate a mask with SAM. And for each of these detections, we add it as a label. So essentially we upload it into the Anchor platform. At the end, we save it and we print the outcome. So down here, we can see our outcome now for each of these tasks, that there's some cars, some pedestrians that are being saved to the individual ones. And if we navigate back, we can see here that the tasks are progressing through our workflow. We can take a look if we're curious. This was our faulty one, but here we have clearly a car and clearly a few cars. So let's go back. And now let's look at our next agent. So now we want to count.
Nico,
Yes.
I just think one point that is really worth raising is that earlier when we saw the workflow diagram with all of the different stages and a different kind of agent happening at each stage, one of the pieces that's really nice about this is that firstly, we have this observability. So we can observe our data all through these different stages and see where these decisions are being made. But also it means that we can reuse these agents, right? So if we have a different project where we wanted to detect a car and then do something else with it, we can also apply this same agent in that use case too. So it allows us to transfer these.
Exactly. You can essentially build up like a library or template of agents. And it's also the vision of Anchor to very soon open source library where people can get access to some of the agents that we are experimenting with externally. Good. So now we want to count our objects. This is super simple. Anything that has above 0 objects goes along one pathway. Everything that has 0 goes along the other pathway. We can see our output here clearly coming. And again, all of these things can, of course, be bundled. Right now, we're just going one by one. But what I see most of our customers are doing is that they're bundling this in 50 or 100 tasks at a time to achieve that scalability and the speed. And this is one of those things you can just leave it running for a morning or an afternoon, and all of your tasks will be processed if you have hundreds of thousands of tasks at once. So let's take a look in our queue. We have 11 that made it to the license plate detector and 2 that got archived. Let's see here. That's correct. No objects. This is noisy data. This is part of our cleaning process with our agents. We don't want to work more with this particular type of data. Then we can navigate to our license plate detector with a pre-trained YOLO. So I've uploaded some weights for this license plate detector that I trained. And now we're just going to run a very simple YOLO model over all of the images and only predict the class license plate, as you see here. We set a threshold, 55% confidence. Again, we can adjust as we want. I just played around to find a nice confidence threshold that fits me. Get the image. We perform our YOLO detection. We convert the YOLO output into an output that Anchor can read. And we set the bounding box. We're good to go. And we can immediately see here that we've created some license plates. So there's one license plate, another one, another one. And that is now run. So now we see if there were license plates, it went up here for OCR. If not, it goes to an expert. Let's see, we have 8 license places, 3 experts. We start by taking a look at the experts. Correct, there is a license plate, but it's very hard to find this one. Just skip to take a look at the next one. And once again, no license plate. On the other side of the aisle, you can check. Yes, there is indeed a license plate here. Yes. Oh, it's a great model, actually. Perfect. So now comes the final step, our OCR. Let's go further down. Stage 4. And just for reference, while we write this, so I have a background at foreign politics, consulting, only dipped into AI 3-4 years ago. I'm non-technical. I do write some Python, do write some code, but most of this was done helping with Claude and ChatGPT. This is done in probably 2.5-3 hours. So there's no excuse for not being able to write your own agents or set up your own workflows. It's super simple. All I did was I fed my documentation. I fed one example. And then by prompting back and forth with the O1 model, you can get really, really far in some of these cases.
Okay. Nico, we've had a couple of questions. Firstly, will you be sharing this Colab notebook after the demonstration today?
Yes, I can clean it up and share it. There should not be an issue.
Fantastic. And also we've had the question of how is the workflow graph kept in sync with the code?
Great question. So the way that these things are kept in sync today is static, right? So if we go back here, each workflow stage has a unique ID, so unique identifier, a hash that we can use, and a name. In our example here, we're just using the name, but you can just pass the unique ID, which means that it always knows what stage it's interacting with. If I suddenly change it up, so let's say I want to change my name or delete the specific stage, I would have to go in and edit my agent. So the agent does not know yet that it needs to update itself. In terms of being kept in sync with what tasks are there, it essentially just goes and polls from the stage. So if I were to run my license plate detector from before, it would not give me any output because there's no tasks here. And this is what Oscar mentioned about the webhook, that what we've seen some folks do is to set up a webhook for this. So that means every time a task hits that stage, it will be pulled for inference. And here the only limitation is what your own infrastructure can hold. But you could host this in a Google Cloud function or like a Lambda function on AWS. Super. So what we do here, let's take the OCR example. I use Easy OCR, a free open source tool. We have our license plate OCR stage. We download our images as before. Then I'm going to pull out the objects called license plate. And I'm also going to pull out the license plate number, which I'll show in a second. Then we process them. So when we pulled out this license plate, we extract the coordinates. We take the coordinates of the bounding box and crop the image, because you only want to get OCR on that particular crop. This is what we're doing here. Then I run OCR over it. I add the OCR example, as you can see down here. It's extracted OCR in some of these cases and added what it reads onto the case. We'll go take a look at it now. So we have our model QA stage. And this is now the point where your annotators can come in, right? So now they just need to review. They don't need to do any annotations themselves. So here we have our license plate and our car. We can see our license plate over here. In this case, we can see here that the agent is not the best, or in this case, the model is not the best, because the plate number definitely doesn't line up fully. We can take a look at the next one. Yes, so this is a little bit better. Let me just, for the sake of this example, open up. You can see here, it got the numbers correct, 6026, and the DS. So the annotator just go in and edit the D in this case. And this is how it goes all the way through. Again, I trained this particular license plate detector very poorly, and you could also use a better OCR model, but it can essentially catch these one by one, where you also see that our different masks are coming in. Now one. Super. So I think we are slowly coming up on time. I hope this was interesting for everyone. We had a really fun time, Oscar and I, preparing this webinar and running it today. It's always fun to do these more live and interactive demos. And it will now go over to a little bit of a Q&A before we end in 3-4 minutes. So we'll now go back here to our screen. And we can start out with some of the questions in the chat, and then we're going to go into some of the pre-written questions that you guys share with us. So we have autonomous attendee here asking about where we host models like YOLO in this workflow. So these are just hosted in a Colab notebook. It's perfect for running experiments and for demoing from my perspective. But I can also send another example afterwards where it's hosted in a Google Cloud function. So this can be an endpoint that's always warm, so a model endpoint, where I can just put that into my particular code snippet. Second question, can a custom hosted model on AWS be used as an agent? Yes, it can. That is exactly the use case that we envision most common on the platform. So while I'm just doing small demos with untrained or very poorly trained YOLO V8 models that I just pull down into Colab Notebook, in production, you'll of course have this in a more production level environment where you can run it at scale. Another question here is this model utilized right now in real time? Yes, everything we've been running today on today's demos have been live. It's always a little bit sketchy when you do these live demos. Oscar and I try to make it feel as natural as possible. I mean, we're always afraid that something is going to break at the when you do like a Colab notebook like this, but everything is live and the inference is just running directly from the Colab notebook. It has a really powerful T4 GPU, so you can actually run it pretty fast in these cases. Good. And then let's go to our pre-recorded questions. So how do I ensure a human in the loop with these agents? Great question. I think we covered it mostly. In the case of Ankor's workflows, we see that the human in the loop is added here at the end of your workflows. You can combine an arbitrary amount of agents together, but we'd always recommend adding a human annotator or reviewer at the end. So these will be people that will go in and validate or verify that the output is correct. You can imagine a panoptic use case where you're panoptically segmenting 15 different classes on videos with some attributes on them. You'd want someone to go in and just verify that the model output is correct. You could also add a router, so you'd route maybe 10% for review and 90% directly to complete. How good are state-of-the-art visual language models at data extraction? Oscar, maybe you want to take this one. I know you've run a lot of examples with some of the new state-of-the-art VLMs.
Yes, absolutely. So I think there's definitely variance between them. So we saw today data extraction. We use GPT to extract those classifications from our building diagrams. I was testing an example of using GPT to review some bounding box classifications, and it performed less well on the geometric use case. But I know that there are some other models that perform better there. But yeah, generally for the classification, especially the text extraction pieces, they perform pretty well.
I ran an example when they opened up for fine-tuning of GPT-4. And it actually works quite well once you fine-tune it. The problem is it's ridiculously expensive to fine-tune it. So in most of these cases, if a VLM does not perform well on your use case, I would pause that and go back to your regular scheduled workflow. Because in 6 months, 9 months, 12 months, there's going to be new developments on these VLMs, and they're only getting better and better and better. And I think once we see Meta coming out with a powerful VLM, that's going to change the game. Because now you don't have to rely on all of the closed source models. You can essentially just take Llama Vision online, fine-tune it yourself, host it yourself, and use that for a lot of these use cases. So that's something that I'm super excited for. We have some questions from the chat. Let me go to them and then we'll go back to the last question here. So Anthony asked, how does the archive workflow step work? Where are the files sent? Great question, Anthony. So the archive stage let's go back here, is essentially another version of a complete stage. So it's a place where your files are stored for now. And when you export your labels, you're not exporting anything from the archives. You're only exporting stuff from the complete. We're still trying to figure out what the best workflow or use case would be for potentially deleting these or marking them as archived within, for example, index. But it's something that we're still planning on, like figuring out what's the best way forward here. And then Yasa asks, I assume these are task agents, as you described in the documentation, in which they're built within the workflow. Can the same agent be used as editor agents? Great question, Yasa. So there's two different things in Ancor. Task agents is what we're looking at today. These are agents to set up these more like scalable workflows where a lot of tasks go through at once. And then editor agents are essentially custom functions or custom agents that the annotator can call from within the editor. So it'll be they might want to just call OCR on a particular bounding box, might want to tighten some bounding boxes, run an inference endpoint. And yes, they're set up in almost the same fashion, and also happy to connect after today's call and discuss both task and editor agents and how you can use them in your workflows with Ancor. And then we have a last question here. Is the agentic flow developed for CBCT data? And do our team plan to webinar this type of data? I think that's a great question. I'll have a chat with Oscar and the rest of the team afterwards to figure out whether or not we want to have a webinar on that, and also how it works. So it will work on all types of data that's supported in Ancor, because we're essentially just extracting the data asset into our model and then running inference over it and adding it back. But it depends on whether or not the data format is supported in Ancor. Oscar, we're on time now, but I keep coming questions. I'll just take a few more if that's fine.
Yeah.
Richard asks, these have been very structured inputs. How about use cases where it is industrial training requirements with lots of documents or videos as input, and the side output is an organized set of training materials following a structured set of learning objectives? Richard, that is a great question. I've not tried a use case like that. I recommend you to reconnect with the Ancor team after today's call. We can jump on a quick call and talk through this particular use case. I think that will probably be the best way forward here. And again, yes, we demo with structured input because it's the most accessible, and it's also the best for these wider webinars where there's a lot of different types of use cases and industries participating. But we have done a lot of different, very niche demos for people that are engaging with Ancor. So more than happy to get that set up, Richard. Ludwig, if I build agents on Ancor, is my data stored on your servers? Great question, Ludwig. No, your data is never stored on the Ancor server. We only register a reference to the URL of the data asset that you have in your own secure bucket. And then whenever we need that asset for visualization, we sign the URL and show it within Ancor. In the case of an agent, it's run on your infrastructure, which means that the asset never touches our platform in that case, and the data stays with you. What is in the Ancor platform is the labels that has been created, but it's of course hosted in a very safe and secure way with both SOC 2 and HIPAA and other security requirements that we live up to. Yes, and then we have a last one here from Shagun Singhai. Since we're using multiple models, one might want to experiment with several model combinations. How do we keep track of those experiments? That is a great question. I think the number one way that I would keep track of this would actually be, instead of setting up a full workflow, just creating a small model evaluation project in Ancor Active, and then running inference with all of your models over your particular data set or particular subsample of your data set. You can compare them visually side by side. I can actually show an example here now when we're on the call, and you can find which model actually performs best. So in this case, let's go here. I'm just importing 3 YOLO models, and I can visually inspect individual predictions from my YOLO models. Again, there's 11,000, so it's going to be hard like this. Or I can display them on top of my images, like this. So it's different ways of setting up experiments to keep track. Good. I think that is all for today. Maybe the final question here, we already touched upon it. We have pre-built agents internally now. We are very soon open sourcing a agents library and an agents repository. And of course, the idea is that a lot of these agents will be accessible from an Anchor hosted version, so where they're within the Anchor platform. But for the specific use cases and niche use cases where you want to keep your data safe, keep your model safe, I recommend hosting it on your end. Super. Thank you very much for joining in today. Thank you for being attentive throughout the webinar and asking a lot of questions. This makes our life a lot easier, and it's very fun to be here today. Have a great day, everyone.
Thanks.
Yes, and we will be sharing slides and any questions for people afterwards.